Whole house fans. The reference used for this section is the Residential Reference Appendices, section RA 3.9, and it can be found at this link on the Energy Commission's website or downloaded from the Files section in the training software. The purpose of these procedures is to verify that residential whole house fans comply with the airflow and fan efficacy requirements specified in the performance standards. The overall training goal is for you to gain an understanding of whole house fan airflow rate, fan watt draw, and determination of fan efficacy testing equipment, protocols, and forms. This training is broken up into 3 sections. First, we'll cover the equipment specifications, then we'll go into the procedures for the whole house fan airflow rate, followed by fan watt draw, and then determination of fan efficacy, and last we'll cover the forms. Pressure measurements shall be measured with equipment having an accuracy equal to or better than plus or minus 1% of pressure reading, or plus or minus 0.2 pascals, whichever is greater. And here to the left, we can see that we have 4 different styles of manometers. The 2 on the top are from the Energy Conservatory, the 2 on the bottom are from Retrotech. It doesn't matter which one of these you use, all of these are acceptable and meet the requirements set by the code. Airflow rate measurements shall be made with an airflow rate measurement apparatus, which is the sensor plus the data acquisition system, that has an accuracy of plus or minus 7% of reading or plus or minus 5 CFM, whichever is greater. Now there are a couple of different types of airflow measurement apparatuses that we can use. These are a couple of examples here, and we will cover these in more detail as we move on. Fan watt draw measurements shall be made with true power measurement systems, which is the sensor plus the data acquisition system, that has an accuracy of plus or minus 2% of reading or plus or minus 10 watts, whichever is greater. And here we have 2 examples. On the right hand side, we have the clamp-on style meter, and then we have the plug-in style. Either is acceptable as long as it meets the accuracy requirements listed here. Authorized diagnostic equipment. System airflow rate shall be measured using one of the following types of apparatuses. You can either use a fan flow meter, which is more commonly referred to as the blower door, a traditional flow capture hood, or a powered flow captured hood. Airflow rate measurement apparatus, the fan flow meter. So the apparatus for measuring the system airflow rate shall consist of a building pressurization and airflow measurement device, subsequently referred to as a fan flow meter, and a static pressure measurement device. So what we see here is more commonly referred to as a blower door. And so what we're going to do is we're going to use this to depressurize the house to the same value, the same pascals as what is required for the whole house fans to operate at their state, which is a negative 10 pascals. So we're going to do that to measure the CFM that the fans are moving at that pressure and record those results. Powered flow capture hood. A device that has the capability to balance the flow capture static pressure difference between the room and the flow capture hood enclosure and meets the applicable instrumentation specifications as previously described. It may be used to verify the airflow as long as a flow capture area at least as large as the whole house fan inlet in all dimensions, and the fan adjustment needed to balance the flow capture static pressure difference shall be provided by either an automatic or a manual control. So this type of flow hood has a fan incorporated in it. So when you are going to take your air measurement, and this is going to be on, the air is going to be moving vertically, it's going to be moving out of the home, so it's going to be sucking the air through this device. When you place that over the opening, the whole house fan itself is going to be running, and it's going to be drawing air through this device, creating a negative pressure within the top portion of that flow capture hood. So what you do is the fan itself is going to be either manually or automatically controlled, and you're going to set it to where it will turn on and it will increase in speed until you achieve a negative pressure, a zero pressure inside the hood. So it's not negative or positive, it's just 0 pascals inside that hood. And then you're going to measure the amount of air. So this takes out any losses that might occur due to trying to draw that air through a much smaller inlet. Velocities are going to go up, but you might lose a little bit of capacity. So this fan helps to account and compensate for that restriction. Traditional flow capture hood shall meet the applicable instrumentation specifications as previously described and may be used to verify the system airflow rate if it has a capture area at least as large as the whole house fan inlet grill in all dimensions. So just like we talked about on the previous one, the powered flow capture hood, it has a fan and it's able to compensate for the negative pressure inside the hood. A traditional flow capture hood doesn't use a fan, it just uses software to calculate and try to adjust for that restriction. Both of them work, both of them have their pros and cons, and both of them need to be large enough. So the top of that hood, they do sell different size adapters for different size grills. So if you're going to use this, you need to make sure that the hood on the device is large enough to cover the entire inlet grill of that whole house fan, and that goes for both the traditional as well as the powered flow capture hood. So either one can be used, as long as that hood is large enough to cover that grill and the hood is rated for the amount of CFM that fan is designed to move. Watt draw measurements shall be measured using one of the following types of apparatuses. The portable watt meter, which covers both the clamp-on style as well as the plug-in that we saw earlier, the analog utility revenue meter, and the digital utility revenue meter. The portable watt meter shall consist of a watt meter meeting the applicable instrumentation specifications as previously described. And that was the accuracy information that we saw. Again, we've got a picture here. You got the clamp-on meter. This is going to be for those hardwired devices. The plug-in style, if it's a plug-in, it's easy just to unplug and plug in, and it's going to read your watts out for you. So either one is acceptable as long as it meets those specifications that we previously described in the training. Analog utility revenue meter. It shall consist of the utility revenue meter meeting the applicable instrumentation specifications as previously described, and a stopwatch that provides measurement in units of seconds. So to perform this verification, you're going to need both of these items, and we'll go through the steps that you use to do that, and you'll understand why you need the stopwatch along with the analog meter. Digital revenue utility meter. It shall consist of the digital utility revenue meter meeting the applicable instrumentation specifications as previously described that provides direct digital display of the watt draw. So most of these digital meters, they're going to have several different readings that they're going to display, and it will just scroll through the different readings. And so you'll just need to take the direct watt draw reading off of that meter. Occasionally it won't have that. You can treat this as it is an analog. It'll have down at the bottom, in this one you can see below the zeros there on the right hand side, it'll have either squares or rectangles that will move generally from left to right. And they are to essentially replicate the black stripe that is on the dial on the analog meter. So every time those dots, and oftentimes I'll have a triangle to the side, every time they move across the screen here, that would be the same as one revolution of the analog meter. So if you're failing to get an accurate watt reading, or it's not showing the watts, you can also use this as an analog meter, just counting the number of revolutions, just like you would on the analog. And we'll go through those steps. Once we go through those steps, you'll understand a little bit more clearly what exactly we're talking about here. Okay, so now let's get into the actual procedures, how we perform these verifications. How do we measure the airflow? How do we measure the fan watt draw? And let's take a look at that. So let's start off with the whole house fan airflow rate measurements. Now the measured airflow rate shall be expressed in cubic feet per minute, or CFM, of standard air, and standard air has a density of 0.075 pounds per cubic foot. Now when the airflow measurement is made at altitudes significantly different from sea level or at temperatures significantly different from 70 degrees Fahrenheit, the airflow indicated on the device gauge may differ from the standard CFM by as much as 15%. Corrections from indicated to standard CFM shall be made using the procedure specified by the airflow measurement device manufacturer. So now, depending, there's a bunch of different pieces of equipment that you can use, different blower doors, different flow hoods, whether it's traditional or standard. So you're going to need to refer to your instruction manual for the specific piece of equipment that you're going to be using, and they'll have this procedure to correct from indicated to standard. It may just be that you plug in different numbers on there. There's a calculation that you have to do. Whatever it is, you need to understand how to do that for your specific device. Now, the reason behind this is the standard air is essentially at 7 degrees at sea level. So if you go up in elevation or you change the difference, change the temperature, the density of the air is going to change. Colder air is going to be more dense, where hotter air is going to be less dense. And then same thing, the higher up you go, the thinner the air gets, it's less dense. And so these are going to affect your readings. So you need to make sure that you're making those corrections if necessary based on the instructions in your manual. When multiple whole house fans are used to comply with the required airflow rate for the dwelling unit, all whole house fans in the dwelling unit shall be operated simultaneously, and the sum of the airflow rate measurements of the simultaneously operating whole house fans for the dwelling shall be determined. So sometimes you'll have just a single whole house fan. It'll be a large one. It'll move all the air that you need for the dwelling because it's a small dwelling. But they also have other styles where they're smaller fans and they're made to be installed in different portions of the home so that you can have it running in one part of the house but not the other. And they don't move as much air, but there's still going to be a total target that you're going to need to hit. So when you do have multiples, you need to have all of them running and take that measurement. And depending on what equipment you're using will determine how exactly you do that, and we'll talk about that when we get into the actual procedure itself. So as we mentioned, when a flow capture hood device is used, the capture area shall be at least as large as the whole house fan inlet grill in all dimensions. So it's going to be either equal to or larger than. It cannot be smaller. Now, whole house fan airflow shall be measured with the dwelling unit window openings configured such that when the whole house fan or fans are operating, a dwelling unit pressure of -10 pascals plus or minus 5 pascals with reference to the outside is attained. This is considered the whole house fan operating pressure, or WHF-OP. So whole house fans, they work on the principle of depressurizing the house so that air is drawn in through windows and into the home, and then it's pushed out into the attic. So the fans are designed to run with windows open. So to test, you need to set the windows so that we get that -10 pascals inside the house. And this is going to go whether you're using the blower door or one of the flow hoods. If you have the windows closed to where you have a negative pressure of say 20 pascals, you're not going to get as much airflow through the fans. And if you have it to where there's 0 pressure difference, so all the windows are open and all the windows and doors and the fans are just running, there's going to be more airflow. So you've got to find that balance. The fans are designed to run with the windows partially opened so that it's drawing air into the house and then out through the attic. So all of these is going to be a standard procedure for all of the test, is to first set up the house, set the windows to where you get that -10 pascal pressure difference before you do any airflow measurements. So let's look at the procedure for measuring airflow using the pressure matching and fan flow meter. So this is going to be the blower door method. So first you're going to want to, the house is just in its natural condition as it was when you walked in. Windows are all closed, fans are off. You're just going to go in and set up your blower door as if you were doing a blower door test, an infiltration reduction test using the depressurization method. You're going to cap off the blower door fan and use 1-minute time averaging for pressure and airflow measurements to minimize any wind effects. Next, you're going to open the windows that are typically opened during whole house fan operations. You're going to go around, and each bedroom should have a window open, and each other room, so the family room, the living room, the kitchen, any main room that has a window in it, open up that window. Next, you're going to turn on all the whole house fans required to meet the dwelling unit whole house fan airflow rate. If it's a multiple or variable speed fan, you're going to need to adjust it so that it operates at an airflow rate that will be greater than or equal to the rate required for compliance. So most often you're just going to go in, you're going to turn them all on to high fan speed. If they're multiple, just turn them all the way up. Next, you're going to adjust the dwelling unit window openings to bring the dwelling unit to the whole house fan operating pressure of -10 pascals plus or minus 5 with respect to the outside. So now you're going to have to go around and start adjusting these windows so that you achieve that negative pressure of 10 pascals. So you're going to go through the house, and if they're all fully open, you may want to start by just closing them halfway and seeing where you're at that pressure. And then you're just going to continually close them a little bit at a time until you hit that 10 pascal target that you're shooting for. Now you're going to measure and record the actual dwelling unit depressurization attained with respect to the outside at the whole house fan operating pressure. So you're going to go back to your manometer that's connected to your blower door, and you're going to measure that the actual pressure with respect to the outside. It should be close to 10, but maybe it's 7 or maybe it's 12. Again, it can be anywhere between 5 and 15, but you're going to try and get it as close to that 10 as possible. Now you're going to turn off the whole house fans and seal the whole house fan inlet openings. So the whole house fan system dampers may be used to seal the whole house fan inlet openings if those dampers close tightly and will not leak. Some of them will, some of them won't. If you're unsure, you can always close the damper and then move on to the next step, and you're going to need to go back and check. And if there's any air leaking through any of those whole house fans, then you're going to need to use another method to seal those off further so they don't leak. Okay, now once you have the windows set for that 10 pascal difference, you don't want to change them at all. So leave them exactly the same. The same window opening configuration is going to be used to establish the whole house fan operating pressure for the blower door measurements that we're going to talk about next. So now we're going to move to the blower door, and you're going to remove the blower door fan cover, and then you're going to turn on the blower door fan and increase the speed until you match the whole house fan operating pressure that you measured in step 5 above. Again, the target is 10 pascals. But you can be anywhere between 5 and 15. So whatever you recorded that you're able to achieve, whether it was 8 or 12 or what have you, you're going to turn that fan on until you get to that same pressure. Once you achieve that pressure, you're then going to record the blower door airflow, which is also what the whole house fan airflow would be. Those window openings at that pressure within inside the house will only allow so much air to come into the house and out of the fan. So that fan is calibrated to know that when this house is at that pressure, this many CFM, however much is flowing through that fan, would be the same amount that would be flowing through the whole house fans if they were operating. Now let's look at the procedure for powered and traditional flow captured hoods. Now that's going to be the same, even though they function a little bit differently. The process for taking measurements the same. The setup for the equipment's a little bit different, and again, you'll want to refer to your manufacturer's instructions for the specific type of flow hood that you have, so that you make sure that you set it up correctly for the type of airflow test that you're going to be taking. So the first step is going to be to go in and open the windows that are typically opened during whole house fan operation. Next, you'll turn on all the whole house fans required to meet the dwelling unit whole house fan airflow rate, and adjusting multiple or variable speed fans to operate. Again, just bump those up to the high fan speed so we can get the maximum airflow rate out of those. You'll then adjust the dwelling unit window openings to bring the dwelling unit to the whole house fan operating pressure of -10 pascals plus or minus 5 with respect to the outside. So again, same steps as what we saw on the blower door. Turn the fans on, adjust the windows until you get to that -10 pascals or as close as possible. Once you're at that operating pressure, you're going to measure the airflow rate at the inlet grills with either the calibrated power float hood or the traditional flow hood to determine the total whole house fan airflow for the dwelling unit. Now, no part of the whole house fan airflow intake shall be blocked or maxed off to accommodate an undersized hood. So again, if that hood with either the standard adapter or the oversized adapter, if it won't fit and cover the entire whole house fan intake grill, you cannot use that. You're going to have to use the blower door method to measure the whole house fan airflow rate. So now let's move over to the whole house fan watt draw measurement. So we covered airflow. Now let's look at fan watt draw, which has to be done. These have to be done essentially at the same time under the same conditions. So just like with the airflow, when multiple whole house fans are used to comply with the required whole house fan watt draw for the dwelling unit, all whole house fans in the dwelling unit shall be operated simultaneously, and the sum of the watt draw measurements of the simultaneously operating whole house fans for the dwelling shall be determined. So you're going to measure them all and then add them together if you're measuring them separately. If you're going to be using one of the utility meter options to measure it, it'll just be all at one time. You don't need to do them individually because it's going to give you the total reading for all those fans at the same time. So let's start with the portable watt meter. So the whole house fans shall be operating at the whole house fan operating pressure used for the airflow rate measurement procedures. So this particular test, the fan watt draw, is going to be done immediately following the airflow measurement. So you're going to do all that setup to do your airflows, and then before you shut everything off, you're going to go and you're going to measure the fan watt draw under those same conditions, the same 10 pascals, -10 pascals with respect to the outside. You'll then measure the watt draw or draws to determine the total whole house fan watt draw for the dwelling unit. Now with these portable watt meters, it all depends on how these things are set up. Most of them are going to be hardwired. Some of them may be plug-in, but you're going to have to figure out which ones they are. Now when measuring the watt draw of units that are wired directly to an electrical junction box, it is recommended to use portable true power clamp-on meters to provide flexibility for isolating the correct fan wires. So again, you're going to need to go to the manufacturer's instructions for your specific model of equipment. You're going to set it up to measure true power watts, and then you're going to need to go up and clamp onto that wire that is providing electricity to that fan so you can measure how many watts it's drawing at that time. Now depending on access and how how close you can get to these, there's a lot of different things that are going to come into play as to which method you're going to use. The easiest is likely going to be the utility meter, simply because you don't have to go traipsing up through the attic trying to find where the whole house fan is and finding the wire that's feeding it and clamping on and all of that. It's just as easy to be down outside at the junction box or the electrical panel and just use the utility revenue meter to measure that watt draw. Now for those utility meters, for the analog meter, it's going to be a little bit more difficult than the digital meter, but thankfully this is a new construction HERS measure, and most new construction is going to have the digital meter, but those don't always work, so it's good to understand the analog meter procedure because it can also be used on the digital meters. So the first thing you're going to need to do is you're going to need to turn off every circuit breaker except the one that is exclusively serving the whole house fans, so that the only power going through that meter is what is being used by those whole house fans. As always, the whole house fans shall be operating at the whole house fan operating pressure used for the airflow rate measurement procedures. You'll need to record the KH factor on the revenue meter, count the number of full revolutions of the meter wheel over a period exceeding 90 seconds, and then record the number of revolutions and time period. So what you're going to do is you're going to have the analog meter, and it has a wheel on it that spins around. That wheel is going to have a black stripe that you can use to determine full revolutions. So you're going to need your stopwatch, and you're going to go up, and while the whole house fans are on and that's the only thing running, you're going to wait for the black stripe on that wheel to come around to the front, and once it comes to the front, you're going to start your stopwatch. Now it needs to run for at least 90 seconds. So you're going to let that stopwatch run. You're going to count how many times that wheel makes a full revolution, and then once the time reaches 90 seconds, you're going to wait for it to finish whatever revolution it's on. When it comes to back to the front and finishes that last revolution, you're going to stop the stopwatch, and you're going to have a result of more than 90 seconds, and you're going to need to know the number of revolutions. So as long as you have those, we can then perform the calculation to convert that information over into a watt reading. So this is the equation that we're going to use to compute the whole house fan watt draw reading. So we're going to take the KH factor, which on the very front of the utility meter, there's a bunch of text on it, and you're going to find the KH value. You're going to take that KH number, you're going to multiply that by the number of full revolutions, and then you're going to multiply that by 3,600. You're going to take the result of that calculation and then divide it by the time that you recorded for the revolutions. Again, this is going to be more than 90 seconds. And so whatever, if it's 110 seconds or 112 or whatever it is, you can take those number of seconds, and that's what you're dividing by. So it's KH times the number of revolutions times 3,600. The result of that is then divided by the time in seconds. And the result of that is going to be your watt reading. So that's your watts for those fans. Once you're done with that, be sure that you return all the circuit breakers to their original positions. Now for the digital utility meter, if it's working properly, again, you're going to turn off all of the circuit breakers except for those that are serving the whole house fans, and make sure that the whole house fans are set up and the house is set up so that you are in the whole house fan operating pressure state. So you're going to have that negative 10 Pascal inside the home. Then you can simply read the watt draw from the digital utility meter digital display. Again, it'll cycle through different numbers, and you're going to just wait for it comes to the watt reading, and then you're going to read that and you're going to write it down. Now, as I mentioned a little bit earlier, if it's not reading the right watts or the watts just aren't coming around, there is the ability to treat it as if it was an analog. It'll have the bars at the bottom that'll scroll across the screen, and that represents the black stripe on the wheel turning around. So you can just do the same thing, wait until those black stripes come across, and then start your stopwatch, count the number of revolutions, stop your stopwatch, perform the calculation, and you will get your watt reading that way. Now that we have our airflow value and our watt value, we'll need to determine the whole house fan efficacy. So demonstrating compliance with the whole house fan efficacy requirements requires simultaneous measurements of the whole house fan airflow rate and fan watt draw. The results of the simultaneous airflow rate and fan watt draw measurements are used for calculation of a value for the whole house fan efficacy. Now these can't be done exactly simultaneous. You can't be taking your airflow measurement at the same time that you're doing your watt draw. Just because you're a single person, you can't do the same, but they need to be done at the same time. So you're going to set the house up, get everything running, measure your airflows, and then you're going to immediately leave everything as it is with the whole house fans running, and then you're going to use whatever method it is to measure your watt draw. So you need to do it as close to each other as possible so that it's tested under the same conditions. So the measured value for fan watt draw shall be divided by the measured value for airflow rate to determine the fan efficacy, which is watts per CFM. So you're going to take your watts, we'll say it's 900 watts, and you have 1800 CFM of airflow. 900 divided by 1800 is going to be 0.50 watts per CFM. So it's a half a watt for every CFM. There's going to be different values, different targets, but that's how you measure or how you calculate the fan efficacy. And now that you have your airflow value and your fan efficacy result, let's look at the compliance criteria. So in order for the whole house fan to comply, the requirements in both subsections A and B below shall be met. So the first one is the measured whole house fan airflow in CFM shall meet or exceed the whole house fan airflow compliance criterion specified on the certificate of compliance. And then B, the calculated value for fan efficacy, which is watts per CFM, shall be less than or equal to the whole house fan efficacy compliance criterion specified on the certificate of compliance. So we're going to look next at where on the certificate of compliance these values are found so that you can make your comparison. So on the CF1R, and this is the performance CF1R, you're going to find a section listed as cooling ventilation. And in this example here, there are two fans that were modeled. They have different CFM values as well as different watts per CFM, different fan efficacy values. So you're going to take your results and you can compare them to the results that were modeled. So for example, if we just had a single fan listed here, we'll go with cooling vent fan number 1. The fan or fans that are installed in the home would need to have at least 2,150 CFM. It can be more, not less. And then they need to be at least 0.14 watts per CFM. These ones can be less and not more. So airflow can be more, but watts need to be less. And then you'll see that there is a number of fans there in column 6. And so for column number 6, if there's just one fan, then that means that they can only install one fan. If there's 3 fans there, then they need to have 3 fans installed. So there's a couple of different ways that they're going to go about modeling this, but you're going to use the number of fans that were modeled for rows, cooling vent fan 1, cooling vent fan 2, and then the number of fans of each fan type to determine whether or not the correct type and number were installed, and compare those values or group those values together for comparison to the CF1R to see if you're going to get a pass or a fail. Now when you fill this out on the CF3R, these values are all going to be calculated for you, so it might be handy just to have that with you on your mobile device, so you can just enter your results right onto the form there, and it'll do all those calculations and let you know if your test results are passing or failing. So now let's look at the forms where you're going to be documenting your results. So we'll start with the CF3R MEC 31A, and this is going to be for the whole house fan, and this is going to be when the airflow and watts are measured per whole house fan. So for a single fan, you're going to measure airflow and watts for that fan. The CF3R MEC 31B is when you're going to measure the airflow per whole house fan, but then you're going to list the total watts. So this is where you're going to have multiple fans. So the airflows are going to be separate, but then you're going to list the total watts. This would be the case where there's multiple fans. So you're measuring the individual airflow, but say you're using the utility meter, so you're only going to get a single watt reading. So it's going to allow you to mix and match these values to get your totals. And then the MEC 31C is similar, but now this is total airflow and then watts per whole house fan. So you're going to get a total airflow. If you're using the blower door method, you're only going to have a single airflow value, where with the flow hoods, you're going to have individual airflow readings. And then again, this is watts per whole house fan, so you're going to measure the watts individually for each whole house fan. And then the MEC 31D is total airflow and total watts. So you're going to have one measurement for each. If you use the blower door and the utility meter, you're going to have a single airflow value and a single watt value, and that's where it's going to be on the 31D. So you have 4 different options, and it's all just allows for that flexibility in the different types of equipment and methods that you can use to measure the airflow and watts. And then the form will add and sum and calculate as needed to get those final values. So as always, if you have additional questions, don't hesitate to reach out to us, send us an email, give us a call, or message us through the training platform.